So here's another example of solving a system of three equations, three variables, using row echelon form and matrices. So start off by changing it to matrix form: 1, 1, negative 5, 3, 1, 0, because there's no y term there. Negative 2, 1, 2, negative 1, negative 1, and 0. So again, our goal is to get this down to a point where it is 1, 0, 0, something, 0, 1, 0, something, and 0, 0, 1, something. So I want to get all these ones and zeros in place, because then that will give me the value of x, the value of y, and the value of z, respectively. I already have this as a 1, so I don't have to do that step, but I do need to turn this 1 into a 0. So I'm going to do that by taking row 1 times negative 1 and adding it to row 2. I need to turn this 2 into a 0, so I'm going to do the same process. I'm going to take row 1 times negative 2 and add it to row 3 to get that to be a 0. So I'm going to do both those steps at the same time. So the first row is not going to change. 1, 1, negative 5, 3. So as I do this with each pair, 1 times negative 1 plus 1 will give me the 0 that I need to put it in this form. And then I take 1 times negative 1. Negative 1 plus 0 is a negative 1. Negative 5 times negative 1 is 5, plus negative 2 would be 3. And 3 times negative 1 is negative 3, plus 1 would be a negative 2. So hopefully you guys are checking my math as you go along and do that. And hopefully you tried this yesterday as I suggested, but I'm going to guess that many people did not do that. So as I go to the next one, 1 times negative 2 plus 2 gives me the 0 as I need, because I'm trying to finish this column out. So I do the same thing here. 1 times negative 2 is negative 2, plus the negative 1 would be a negative 3. Negative 5 times negative 2 would be a positive 10. 10 plus the negative 1 is 9. And then 3 times negative 2 is negative 6, plus the 0 would be a negative 6 there. On the second row, I can just change everything to its opposite. The opposite of 0 is still 0. The opposite of negative 1 is 1. The opposite of 3 is negative 3. And the opposite of negative 2 is a positive 2. I could show that as a complete new step, but I'm lazy, okay? But that gets me my 1 in place here. So now I need to get the zeros in this column. So I'm going to take this 1, I'm going to take row 2 times negative 1 and add it to row 1 to get that to be a 0 in this spot. And then likewise, I want this to be a 0, so I'm going to take every pairing using that 1. I'm going to take row 2 again times 3 and add it to row 3 to turn that into a 0. So the middle row, not changing. 0, 1, negative 3, 2. So as I go through and do this one, 0 times negative 1 plus 1 is still a 1. That's why I had to have a 0 there, so that way that doesn't change. 1 times negative 1 plus 1 is 0. Negative 3 times negative 1 is 3, plus negative 5 would be a negative 2, I believe. 2 times negative 2 is negative 2. Plus 3 is going to be 1. So hopefully I did that correctly. Now working with this one, 0 times 3 plus 0 is still 0. That's good. 1 times 3 plus negative 3 is 0. That's good. That's what I needed there. Negative 3 times 3 is negative 9, plus 9 is 0. And then 2 times 3 is 6, plus negative 6 is 0. So, what happens here is we now have a situation where the last equation has canceled everything out, and it's become 0 equals 0. That means that's infinite solutions. So how do you handle that? Well, what you do is instead, I'm going to change this to a 1 and assign this to be A. Because I have, it doesn't matter, I can do A, B, C, D, whatever, but my ordered triple is going to have an X, a Y, and my Z is now A. There's infinite solutions, but I need an ordered pair that will take care of that for me. Okay? So, I now have a 1 in that spot. So what I could do is keep that row the same, 0, 0, 1, A, because that's going to be my A there. I want to get rid of this 3, so I'm going to multiply row 3 times 3 and add it to row 2. When I do that, 0 times 3 plus 0 is still 0. 0 times 3 plus 1 is still 1. 1 times 3 plus negative 3 is 0. A times 3 would be 3A, plus 2 would be 3A plus 2. That is my formula for finding Y if Z is A. Then I'm going to do the same thing to turn this 2 into a 0. So I'm going to take row 3 times the opposite of that, which is 2, and add it to row 1. When I do that, 0 times 2 plus 1 is still 1. 0 times 2 plus 0 is still 0. 1 times 2 plus a negative 2 is 0. A times 2 plus what I have there is 2A plus 1. There is my X component and the formula for my infinite solutions. Yes, there's infinite solutions, but they all have to follow that pattern.